So just for your information about your test, your first test was February 23rd on Tuesday. Chapter 6.1 to 6.6, the whole chapter 6 includes 6.7, which is application we did not cover, and then 7.1, 7.2, 7.3. So your first test is going to be on February 23rd, Tuesday. It's going to cover chapter 6.1 to 6.6, and then 7.1 till 7.3. So don't forget about this. And then usually the test is a bit early. So those students who make sure you put this in your phone or something else. 1 o'clock, instead of our class starts at 2 o'clock during the test day, the 23rd, February 23rd. The class starts at 1 o'clock, which is a 30 minutes review for the test one, which is optional to attend. If you want to come, sure. If you don't want to come, it's up to you. I would really strongly suggest you guys to show up because a lot of students show up and do really well in the test. And then the test is actually from 1:30 to 3 o'clock, test one. I haven't set up the test yet. It's still early for the test because February 23rd is a test. I think it's 3 weeks from now. But I did last weekend. I think I told you guys to do a cam scanner upload to the D2L file. I don't know how many of you guys did it or not. So please download a cam scanner or download if you have a scanner at home, download a scanner, and then please scan any 3 non-private, non-confidential documents you want, and then upload it to D2L. So when you go to D2L, you just need to go under. This is how you're gonna do it in my test now, because I don't want to send picture. I don't want to send text. Because I gave a test last Thursday and it is horrible. Oh my God, it is like, so it's only 15 students at the time. Imagine I got 35 of you guys doing this. I was like, I'm gonna pull my head out. So so for me is I want you guys to go ahead and go to the D2L website, pre-calculus, and then go underneath the assessment and then assignment. And then you will see the upload here. So please upload your PDF under here, your PDF file, you upload it. And then during your first test and your second test, it will be pop up test 1, test 2, and so on. So I would recommend that you guys please when you finish doing your test, please scan it with the cam scanner and please save as a PDF. I will look at your submission. I haven't looked at all your submission yet, but I will look at all your submission here. And then this is how you submit your test now. So you'll be a test 1. So submit like how you guys, I know that the 14 of you guys did submit. So please make sure you guys do this, and I will look over at your your submission. This is very important. This is for your test. So those students who do not know, please do that. Very important. Anyone have any questions for me? Anyone have any question for me? So again, first test, 3 weeks from now. How you submit your test is you have to use a cam scanner and submit through D2L. So this is the test 1 that I'm talking about. Next thing I want to talk about is the review. Where can you get your review? You can get your review from your textbook. So if you go, or ebook. So if you go underneath to your ebook and then you go all the way till the end here, that's what we call as a chapter test. So if you click on this chapter test, this is the review for test this coming up. It's just only for chapter 6. And don't forget your test includes 7.1, 7.2, and 7.3, which you will go to the chapter test on chapter 7. So I would really highly recommend those students who are studying for my test, this is where you're gonna review it. Yeah, Marcel, I'm sorry, I did not hear anything back from Tom. I didn't know anything about the accommodations yet. But for you guys, submission from you guys is probably to Tom, or you send it to Tom or something else. I will talk to Tom again because I haven't heard back from him for like 2-3 weeks since the school starts. So I will talk more about it once I will send an email to him today. So yeah. I call him actually and see what's going on. So those students who have accommodations or 1.5 hours or extended time to take a test, you will I will talk more about that. I will send you guys an email, so don't worry about that. So I still haven't heard back from Tom. So this is for the review for your test. So make sure you guys do this review because it's very, very important and it is very similar. Again, this is a lot of questions here. There are 20 questions here. The last few questions you do not need to do because they are word problems. So there are word problems, but not on this. Remember, we skipped 6.7. So the last two sections here is from 6.7. So you do not need to do that. You do have word problems like change it like the law, like using the sector or using the you will have word problems in this case, but it's a different word problems. Okay, the one that come from 6.1 about Ferris wheel or about how the truck moving and stuff like that. So you did 6.1 some word problems. So that is the only word problems you will get. Is coming up in 6.1 or maybe a bit of 6.2. So I will tell you more about your test when it comes. Okay, so this is a test here. So anyone have any questions for your homework 6.4, which is due tomorrow night? Anyone have any questions on 6.4? We're gonna start class already. So anyone have any questions on 6.4? You can either type in the chat room or you let me know. 6.4 homework, anyone? Okay, if you do, how do you put in from question 50? Matt say 15, this one. How do you input answer? Is that 15? Because this is multiple choice. I think you're talking about 14, right? Matt, you're talking about 14, right? So those students who are doing question 14, how do you, step 2, yes. How do you input your answer for step 2 here? Is this is the one that you input the step 2 here. So step 2 for question 14. Anika, you had to tell me what questions you have. So how do we input this question is you solve for x here. So as you guys remember that to input step 2 answer is you take the bx minus c equals to 0. And you take the bx minus c equals to 2 pi. And so the bx minus c in this case is pi x. This is the bx minus c. So you will take pi x equals to 0 and pi x equals to 2 pi. And then, then you solve for x in this case. So you divide by pi. So x in this case is 0. And then you solve for x in this case, you divide by pi. X in this case is 2. So in one cycle, you will start at 0. This is where your starting point at. And you will end at 2. So this is how you do step 2. How you put the interval is you take the bx minus c and you solve equals to 0 and equals to 2 pi and you solve for x. And then once you solve for x, that number is your cycle. So it will be 0, 2 in brackets. Okay. If you did your the coordinates, remember there's 5 coordinates. Okay. So this is where it starts is at 0 and it ends at 2. So this is what it means by this step 2 here means. That means that in one cycle, it will start at 0 and it ends at 2. So when you draw me the graph 0, 2, this is you will get one full cycle here, and sine is a hill and a valley. So this is the meaning of step 2. So if you did doesn't know how to do step 2, you just need to look at the coordinates. And the coordinates in step 3, you can tell that the coordinates for x starts at 0 and it ends at 2. So that's the reason why that the interval that following this is from 0 to 2. That means this is one cycle here. You got it, Matt and Anika? Okay, so make sure that you just look at the first and the last. That is how we do it. And it's always equals to 0. And it's always equals to 2 pi. It's because there's one cycle for sine and cosine. Okay. Later on in tangent, we will cotangent and so on. We will change this into a different number here. Okay. Anyone have any questions on 6.4 here? Anyone have any questions?
30.
I'm sorry, someone say something. Kun, what's that?
Question 30.
30. Okay, 30. 6.4, 30. Okay, so this is a word problem. So this word problem says that it's given us a function of this p equals to 100 minus 20 cosine of 7 pi t over 3. So this is the functions. This is used for to measure blood pressure. P is millimeters in mercury, and T in seconds for a person at rest. So this is measuring your blood pressure. Find the period of the, yes, this is 6.4. There's only one section homework due today, 6.4. So find the period of this case. So the period in this case, the formula in this case is 2 pi over B. Can someone tell me what is B in this case? If you look at this function, what is your B?
80?
No, B is not 80.
Negative 20?
No, that's not your B. This is your A. So, so I can rewrite this question to become negative 20 cosine 7 pi t over 3 plus 100. I can move this 100 to the back. So your B in this case is 7 pi over 3. Yes, Kun is correct. So this is your B in this case. Okay, this negative 20 is your A. The 7 pi over 3 is your B, and the 100 is your D. And you don't have a C in this case. Okay, so now we will plug the 7 pi over 3 into here, your period. So as you guys know that when you divide, you can actually multiply. So it's 2 pi times, it's 100. This is 100 here. So if this is 100, I can put the 100 at the back. That's your D. This is your 100. That's your D. So I will change it to multiply, and then I flip-flop this fellow. So it'll be 3 over 7 pi. And the pi will cancel out. So this is actually 6 over 7. So your period in this case is 6 over 7. That is how you figure out your period. And then you're going to figure out number of heartbeats per minute. So how do you figure out your number of heartbeats? This is part B. Per minute, number of heartbeats per minute is you take 1 over by your period. Okay, so in order for us to figure out the number of heartbeats per minute, you put 1 over by your period. But don't forget, this is all in seconds. So if you want to convert that to minute, you need to multiply this by 60. So we have conversion from second to minutes. So you know 1 minute is 60 seconds. So I multiply by 60. So 1 over P means you take this. This is your P now. And you flip it. Because 1 over means you flip it. So it's 7 over 6 times 60. So this is actually 70. Because this one can reduce, become 10. So this will be a 70 heartbeats per minute. So this is how we do the last question, number 30 here. Yeah, I moved the 100 to the end. Yep. So I just move this 100 to the end. So it will. Sometimes your questions are when you do the question like this, you can move your D back and forth, right? Same thing like your slope. When you guys do your slope, instead of y equals to mx plus b, instead of y equals to 3x plus 10, I can write it down as 10 plus 3x. It's the same thing, right? You just need to move your 10 behind. So make sure you guys, this is the same thing. So when you guys do your homework, if you see some number in front here, that is your D. Okay, you can move it at the back. Yep, Samsung, you're correct. Anyone have any questions on 6.4 before we move on to 6.5? Okay, so we will do 6.5 in this case. So what is 6.5? If you look at 6.5, 6.5 is where you begin to graph your tangent, your cotangent, your cosecant, and your secant function. So let's graph the tangent and the cotangent functions. So, so how do we graph your tangent and cotangent if you do not know it? This is usually how we start graphing it. Is if you remember that unit circle that you learned in well, unit circle, Fred. So this one. So remember the unit circle that I teach you last time. Okay. So if you do not know how to graph a sine and cosine, you can always use this unit circle to do it. So now we're going to graph tangent. So if you remember tangent, we will use y over x, the y coordinates over by x coordinates. And if you remember last time how we do sine cosine graph, we always we plug in numbers inside here, right? So this time we will use y equals to tangent x. So this is coordinate x and y. And we always use the 0 degrees, the pi, 0 degrees, 0 radian, pi over 2, pi, 3 pi over 2, and 2 pi. This is the same thing we're going to do for almost all your trig functions. We always use these 5x values. So now we plug in 0 in here. So you will get tangent 0. So in order for us to use this picture to do tangent, 0 degrees, so many things popping up here. Sorry about that. I need to, a lot of things in my window here. Yep. So in order for us to do the 0, so 0 is this one. So for tangent, we have to take your y value over by your x value. So your y value in this case, this is a big. So your y value in this case is 0. And your x value is 1. So this is 0. So at tangent 0, you will get 0, which is this point. Pi over 2. So in order for us to figure out tangent pi over 2, you have to use this coordinates, pi over 2 coordinates, and it's 0, 1. And again, for tangent is y over x. So it's 1 over 0. This is undefined. So you notice that when you get tangent pi over 2, it is undefined. Undefined for us is a dashed line. Okay. And then we do tangent pi. Tangent pi will be this coordinates. And it is going to be 0, negative 1. So it's 0 over by negative 1, which is 0. Okay. So at tangent pi, it will be 0. And then when you do 3 pi over 2, which is this coordinates, and if you take negative 1, and the value for this is negative 1 over 0, so this will be undefined also. So at negative 3 pi over 2, you will get an undefined case. And then at 2 pi, which is the same thing as 0 because it is 360, so tangent of 2 pi will be 0 back. So if you look at this, we only have a point and a line and a point and a line, and you know that the next undefined case will be at negative pi over 2. And then the next one we have is 3 pi, negative 3 pi over 2, kind of like a reflection on the y-axis here. Yep. So, so we cannot draw a graph with just one point with all this undefined. So we begin to insert another one, which is pi over 4. This is a special one. The reason why is because tangent pi over 4. So if you look at pi over 4 is this one. It's square of 2 over 2 over square of 2 over 2. So if you take your y over x, they are the same. So if you take this divided by this, you cancel out. you get 1. So when you have a pi over 4, your tangent will be exactly 1. Okay. If you use negative pi over 4, negative pi over 4 in this case is actually 7 pi over 4, because if you go down, negative means you go this way because it go clockwise. So it's the same thing as this, and you find out they're exactly the same. So when you divide this, you get not 1, you get negative 1 because this value is a negative. So when you do a tangent negative pi over 4, you will get negative 1. So at negative pi over 4, you will end up with a negative 1. So what you can tell here is with these 3 points, you can draw me the tangent graph. And the tangent graph looks like a cubic. So if you know x cubed, this one looks very similar to x cubed. The only difference is that it will bounded by this vertical asymptote, means that your tangent graph will have a period here. So this is considered a period for one period for tangent graph. Okay, and so one period is actually pi, because from pi over 2 to negative pi over 2, the whole period is pi. So if you remember last time sine and cosine, the whole period is 2 pi, but this time your period is pi only for tangent. Okay, so remember last time when you do amplitude, tangent does not have amplitude. Okay, the reason why is because this one keep on going to infinities, so it doesn't have amplitude. The period is going to be pi over b. Remember last time for sine and cosine is 2 pi over b, but this time it is just pi over b. It's because the period here is only 1 pi instead of 2 pi. Okay, the phase shift is still b over c, and then the d in this case is your up or down. So the only difference between your tangent graph and your sine and cosine graph is your period, and it doesn't have any amplitude. Okay. You guys all right here with this one? And if I want to draw another tangent graph, it will look something like this.
Which one does it have an amplitude?
Tangent. So the tangent graph has no amplitude.
So for the tangent graphs, the range is infinity?
Yep. So the domain, I will talk about domain and range. Yes, your range in this case is all real numbers. That means it goes from negative to positive infinity. Your domain in this case is all real numbers, except all the vertical asymptote. Now, how do you figure out this? Is because it's pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, negative 3 pi over 2. So what we're going to do in this case is we're going to do pi over 2 plus k pi. Okay, where k in this case is integers. You guys know what are integers? 0, 1, 2, 3. So if you put k as 0, you get pi over 2. You got pi over 2. If you put k as 1, you will get 3 pi over 2. And if you, which is this one, if you put k as negative 1, you will get negative pi over 2, which is this line. So you find out that this is how we figure out your domain in this case. So a lot of students will ask me, how do we figure out this formula? It's very easy. First thing first is this k pi is based on your period, because your tangent has period as pi. So put k pi. And then this pi over 2 came from your vertical shift here. Okay, so if you have your vertical asymptote is pi over 2, then you will have pi over 2 plus k pi. Let me give you another example here, so you guys know what's going on, how we figure out tangent. So let's say you got another tangent graph, but this time your line is gonna be negative pi over 8. And this will be pi over 8. Usually when you have tangent, graph, these two are exactly the same if your phase shift is 0. Okay, so we are talking about when phase shift is 0 here. So your tangent graph will look something like this. Now, how do you, and then the next one is, does anyone know what will be the next one will be? Because in a test, you need to figure out at least 2 cycles. So can someone tell me what is this value is? So if you doesn't know, figure out your period first. And what is a period in this case?
2 pi over 8.
2 pi over 8, which is pi over 8 and pi over 8. That's why you get 2 pi over 8. And which can be reduced to become what? Pi over 4, right? So what happens when you take this number plus 2 pi over 8? So this will be what? 1 pi over 8 plus 2 pi over 8, you get 3 pi over 8. You will get the same shape. Okay. So my question to you now is, what is your domain? Your range is still all real numbers because it goes from negative to positive infinity for your range. But what is your domain in this case? Anyone?
All reals except 2 pi over 8 plus k pi.
2 pi so first figure out what is the distance from here to there is pi over 8 plus k pi over 4. Okay, where is the pi over 8 come from? The pi over 8 comes from this. And where is the k pi over 4 comes from? It comes from this, the period.
Okay, so the first part, the pi over 8 is half of the period?
No, the period is actually measured from here to here. So this is pi over 8. And this is also pi over 8.
Okay, but like if there's a phase shift, how would you find that first number?
Which first number? Okay, I'll give you an example because I'll give you another example. So example will be like tangent pi x minus pi over 4. So your period in this case is going to be what? Pi over b. What is your b in this case?
Isn't it just b? Or not pi?
Pi, yes, because b is next to your x. So pi over pi in this case is 1. So this is your period, is 1 now. And then your phase shift is c over b, right? Not b over c, sorry. It's not b over c here. It should be c over b. And what is c in this case? This is your c, right? Pi over 4 divided by b. b in this case is pi. But in this case, I can change this division. I flip him. So the pi and the pi will cancel out. It's 1 over 4. So what happens to your graph here? Your graph will used to be at pi over 2, negative pi over 2, pi over 2. Now your phase shift is 1 over 4. So that means you move 1 over 4. So this asymptote used to be, let's do that. Remember last time we take bx minus c equals to 0 and bx minus c equals to 2 pi. But this time we don't use that. So we will use bx minus c equals to, let me redo this question again because I have no room to squeeze everything here. But what I want to tell you here is this is what's going on. And I'll do this question in another new page here. So at least you can see it. So because I have no room to squeeze everything here. Okay, so same question because I don't have room for that. Pi x minus pi over 4. So we find out that your period in this case is 1 and your phase shift in this case is 1 over 4. So in order for you to graph this, you have to figure out your asymptote. So what you do in this case is you take pi x minus pi over 4, your bx minus c. This time you're making it become negative pi over 2 and pi over 2. Why we use this number instead of using 0 and 2 pi is because for your tangent graph, one period is actually measured from negative pi over 2 to pi over 2. So that's the reason why that this is considered one period here for tangent. So that's the reason why that you were using these two number instead of 0 and 2 pi. This is for tangent case. Okay. And you solve for x like what we did. So when you solve for x, we add pi over 4 here. And then, so you got pi x equals to negative pi over 4. Negative pi over 2 plus pi over 4 is negative pi over 4. And then you divide this by pi, which will cancel with this pi. So this is actually is negative 1/4. So this tells us that this asymptote is no longer at negative pi over 2, is at negative 1/4. And then you do the same thing for this case, you add pi over 4. So pi x in this case is 3 pi over 4. And then when you divide the pi, this pi and pi will cancel out. So what you end up is 3/4. So this will be 3 over 4. And remember last time that this is at 0. So you also need to do one for this case. So you take this pi x minus pi over 4 equals to 0. The reason why we do 0 here is because of this 0 case. So we solve for x again. So pi x in this case is pi over 4. And then when you divide by pi, this pi and pi will cancel out. You get 1/4. So this 0 is no longer at 0. This is at pi over at 1/4. So your graph will look something like this. Where so what you guys do here when you have a tangent graph is you have to do it 3 times. The first 2 times is for your vertical asymptote. And this is for your x-intercept. And you do not need, like, remember when you do your sine graph last time, you had to do the whole 5 coordinates, remember that? And then you had to do the transformation of all the 5 coordinates and then you point those out. But for tangent graph, you only need to do 3 things. You need to figure out what is your vertical asymptote, the beginning and the ending. This is beginning, this is ending. And then you also need to find out your x-intercept here. And then you just draw it out. Okay, and then the rest you just follow. So this is negative 1/4, this is 3/4. So the next one that we have here, because your period is 1, so you just add 1 here. So 3/4 plus 1, which is 7/4. And then for this case, you also need to add your period because this is 1/4. Your period is 1. So when you add 1 here, you will get 5/4. So this is your graph in this case for the second one. Yes, I will show you how to do it in your homework. So what is the range is all real numbers. How you figure your domain here is all real numbers except, anyone know how to do it? What is the value that we have on this? So you can either take this number or you can take the vertical asymptote or this one. I like the positive one, so I take the 3/4 plus what is your period? My period in this case is 1, so put a k on it. So 1k, or in this case just k. So this is your domain for this case is 3/4, all real number except 3/4 plus k, and k in this case is 1, 2, 3, 4, 5, and 0, 1, 2, 3, negative 1, 2, 3, 5. So this is how we figure out your domain. You guys doing okay here?
Yeah, I have a question. So because there's no amplitude, would it matter if there's a number before t, 10?
Yes. If you like, you mean like a 3 here?
Yeah.
Yep. Yes, this 3, although we don't have any amplitude for this 3 will make this skinnier.
Oh, okay.
So what happens if you have a 3 here, your graph will become a little bit skinnier, like 3 times skinnier.
Is it because of the phase shift, the C over B part?
No, it's because of this 3. This 3 is actually your vertical stretch or horizontal, vertical stretch or vertical compress. So when you have 3, this whole thing will pull up like 3 times.
Okay.
And if you have 1/3, then it will be a wide one. So it will be like even wider. So
Okay.
it become like that. Okay. Now I can show it to you what happens with this Desmos graph so you can see what's going on. So if you just type Desmos graphing, you can figure out what's going on to the tangent graph. So this is a very, if you know people who like, okay, what's a graph? So if you type like tangent x, so this is a tangent x graph, and you can tell that they're all not in radian. They're all, so imagine pi is 3.142, so that is 3.142. This is considered as your pi. Okay, so if you type let's say 3 tangent x, so you notice that it become, what happens is this used to be 1 here because this is pi over 4. You multiply everything by 3. So that's what happens, that your graph is, it still have a vertical asymptote at pi over 2 and negative pi over 2, but it is more, we call it kind of a straight line, but it's not straight line, because once you see right through here, it is, so if I zoom right through here, it has a little bit curly going on here. So it's not actually a straight line. But if you do a third of x, a third of tangent x, you notice that the graph, the green graph, this is the wider piece. Okay, so this 3 and this 1/3 is the what we call as your vertical shift, your vertical compress and the vertical stretch. So when you have a 3, it become the blue line. When you have a 1/3, it become a green line. You guys with me? We come with this more. Yeah, this is called decimal graphing, which is really helpful if you guys like to study this from your visual learner. Okay, so let's talk about the tangent. So like this case, so let's talk about him. Yes, again, in your test, you do not have multiple choice. So the only difference with this question is your period. Your period in this case is pi over b. What is your b in this case? Anyone wants a b here? Anyone? No, again, period is like the slope next to your x. So if you know b is like your slope next to your x. What is yours? So it's 1/4. Yep, it's a quarter. So that's your b. Okay. So 1 over 4. So if you change this, this is multiplied by 4 over 1. So it's actually 4 pi. So your period now is 4 pi. Okay. So what you need to do next is you take the bx minus c. In this case is this is x, sorry, x over 4. Make it equals to negative pi over 2. And then you do the same thing, make it equals to pi over 2. So you multiply this by 4. So this 4 will cancel. So what I get here is negative, this will cancel, become 2, negative 2 pi. And I multiply this also by 4. So this will get also 2 pi. So now what happens to my vertical asymptote is going to be from negative 2 pi to 2 pi. Okay. Then you take the same thing to find your x-intercept. So you make this equals to 0. So x over 4 equals to 0. This is to find your x-intercept. Multiply this by 4, x in this case is still 0. So your x-intercept is still 0. And in this case, we don't have a MA. We don't, it's 1. So it's a normal size tangent like that. And you can tell what is the next. If I want 2 cycles, you just need, yep, in the test, I need 2 cycles. So can someone tell me what is this number is for the cycle 2?
6 pi.
Because your period is 4 pi. So you just add 4 pi, this is 6 pi. And then as again, it is a cookie cutter. So you just do the same thing here. And this is 0. So what is this gonna be is you add another 4 pi. So 0 plus 4 pi, this is 4 pi. So your graph looks something like this. So I think you can match it easily. But my question here is, what is your domain here? I know the range is all real numbers. So all real numbers except what? Anyone? Because in your test, I will ask for domain. Except what?
2 pi.
Plus
Um,
period. Don't forget the period.
4 pi k.
Oh, 4k pi. Yep, this is correct. Yep. So in order for us to figure out this, again, you use the first positive vertical asymptote plus the period, and then put a k next to it. And this is how you figure out your domain here. Questions? And this is how you do your tangent graph. You do not need to do any crazy work like you do in sine and cosine.
And so it's always 4k or like k pi, not pi k.
Yep. So it's usually take your period and then put a k next to it.
Okay.
And that's how you do this one.
Okay, thank you.
And then yep, and this one is always come from the first vertical asymptote. Question? All right, so you know this is what it looks like, a tangent graph. But if you put a negative in front of it, then this tangent graph will going the opposite direction. You guys with me here? Okay, so when you have a negative tangent x, it will go the opposite direction. You can also use your decimals to figure out. So if you put it down a negative tangent x, it go the other way around. It still cross on the same x-intercept. You still will have the same vertical asymptote, but you just flip it on the x-axis. Okay, so I want to point out to you guys that if you guys see a negative sign, make sure you just flip it around. You know, we got the positive, then like an hourglass, do the other one. Okay, you guys know hourglasses, right? So this graph will look more like this one because it goes from 2 pi to 2 pi. And then state the period. The period in this case is 4 pi, which is the one that we just did here. Your period is 4. Don't put a k next to it. If the question just asks for period, 4 pi. If a question asks for domain, 4k pi. So make sure you guys know the difference between the question asks for period and the question asks for domain. Question about tangent graph before we go with the cotangent graph. So a bit less work for tangent and cotangent. Okay. So cotangent data, if you know, we do for tangent, we do y over x. This time we use x over y. So now again, we use the same feature as the tangent graph. So this is back to the basic drawing graph. So if you doesn't know how to draw a cotangent graph, you just use back these coordinates, which is the same for all 6 trigonometric functions. So now you put 0 here, cotangent 0. So again, if you do not know this, what is cotangent 0 is, then you have to use the unit circle. So some students ask me, when do we use this unit circle? Is first, if you doesn't know how to draw this basic sine, cosine, cotangent, tangent graph, then you use this basic circle. And the other time that you use this is when they ask you for exact value. So if a question says, give me an exact value, means no calculators, you have to use this. So as you know that cotangent is x over y. So what is your x value for 0? X value is 1 and y its value is 0. So this is undefined. So when you draw a cotangent graph, when it's at 0, this fellow is undefined here. Undefined means that vertical asymptote. So it's a little bit different from tangent. And then you put in down the pi over 2 here. So pi over 2 is 90 degrees, so which is this fellow. And it's going to be x over y, so it's 0 over 1. So this is going to be 0. So at pi over 2, this will be at 0. Cotangent pi, if you look at this, again, because it's -1 over 0, this will be undefined. So at pi, this fellow will be undefined. And then at 3 pi over 2, so you do cotangent 3 pi over 2 will be 0 over -1 because it is going down this way. So it will be 0. So at 3 pi over 2, this is 0. And the last one, when you put 2 pi, which is the same thing as 0, you will get yourself an undefined. So at 2 pi, you will get yourself an undefined cases. Now, again, this is the same thing as tangent because we are lacking of coordinates. So we will insert pi over 4 in here. And what is cotangent pi over 4? Cotangent pi over 4 is this over that. Square of 202 over square of 202 is actually is 1 because those two will cancel out. So at pi over 4, this is actually at 1. Okay. And then the next one, because we don't go negative, we all go positive here. So if you put 3 pi over 4, so when you do 3 pi over 4, which is this fellow, when you divide this, they will cancel, but you end up with a -1 because this number is a negative. So this you will get a -1 for 3 pi over 4. So at 3 pi over 4, which is right over here, it will be -1. So what you think about the cotangent graph is your cotangent graph is actually looks the opposite of tangent graph. It's a cubic function, but it will look opposite as a tangent. This is a cotangent graph. The period for it is still pi. Okay, it's still pi because every single one has a period pi. So again, when you do cotangent graph, there is no amplitude. Your period is pi over b. Your phase shift is still c over b. Your domain, you guys know how to figure out your domain, all real numbers except what? If you look at this, because it starts from 0, then pi, and then 2 pi, and then 3 pi, and your period is pi. So this is going to be just k pi. Okay, because your initial vertical asymptote is at 0. So 0 plus k pi, your period pi here. So your range is still all real numbers. Okay, so this is how you do your cotangent graph. So you go a little bit opposite of tangent graph. So like this case, can if you want to do question number 10 here, so they ask you for 1/2 of cotangent y equals to 1/2 of the cotangent pi x. So now we have our period is pi over pi because our b is pi. This is 1. We don't have any phase shift here because our c is nothing. So what we do here is, remember last time we take the bx minus c equals to 0 and 2 pi, and then for tangent is -pi over 2 and pi over 2. For this cotangent case, you will take bx minus c equals to 0, and also bx minus c equals to pi. So this is how you figure out your vertical asymptote. And then for the x-intercept, you take bx minus c equals to pi over 2. Because pi over 2 is your x-intercept. So for us to do this graph, you just need to do what I just did here, is you take bx minus c equals to 0 and equals to pi, because that is your original vertical asymptote for cotangent. So bx minus c in this case is just pi x. This is your bx minus c. So pi x equals to 0 and pi x equals to pi. So that means your x in this case is 0 and your x in this case is 1, because pi over pi is 1. So what happens is this is your vertical asymptote. It will be at 0 and it will be at 1. Okay. Next thing we're going to talk about is your x-intercept. So in order for us to figure out your x-intercept, is you take the bx minus c equals to pi over 2, which is originally is at pi over 2. So again, this is pi x equals to pi over 2, and the pi and pi will cancel. So this is going to be at 1/2. Okay. Used to be look something like what I just draw in blue here. You'll be go in here, but because of the 1/2 that you here have, this graph will become wider. Okay. So if you have a fraction, it'll be wider than what you have over there. So when you want to make it wider, you just pull it down a little bit on the x, and then you just kind of go flat down here. So this is how you make your graph. If you have like 1/2, 1/3, 1/4, you make it wider like that. Then you do the same thing. This will be 3 over 2. And then the next one that you have here is, if I have, it will be 2. So you will have to draw a bit wider than that. So for us to make it wider, usually this is like very close to your x-axis. Okay, so this is how we do this graph. So the graph that I'm looking here will look something like this. Yep, this one. This one. Yep, it goes from 0, 1. So it goes. Yep. Now, next thing I want to point out to you is your domain and range. So does anyone here know what is your domain here? Range is all real numbers. Domain is all real numbers except what?
Except, wait, what's the period? The period's 1, right?
Yep, period is 1.
So just k, except k?
Yep, except k. There you go. Yep. Because our vertical asymptote is at 0, so that's good news. So we don't need to put 0 plus k pi, but our period here, k times period, our period is 1, so k times 1 is k, so just k. You guys all right here? Tough? Period in this case is 1. All right. Questions for me so far with sine and your tangent cotangent. So again, tangent and cotangent, you just need to draw period and phase shift, and then bx minus c if it's 0 on pi for cotangent. Tangent is negative pi over 2 or pi over 2. If you doesn't know about, oh my god, I forgot everything, it's in my notes. So if you look at my notes here, it is right over here. Do you see this one? So for tangent, to construct your vertical asymptote, you take your bx minus c equals to negative pi over 2 and pi over 2. For cotangent, you make it equal to 0 and pi. So you can tell by looking at. So this is how you construct your vertical asymptote here. Now we're going to talk about cosecant and secant. So usually when you do cosecant, so if you want to draw a cosecant graph, does anyone know what is a reciprocal of cosecant? Anyone know what's sine? So you will need to draw a sine graph first. Okay. So this is every time when you guys want to draw a cosecant graph, you have to draw the sine graph first, and then you have to erase. So you guys remember sine graph is a hill and a valley, right? It goes from 0, pi over 2, pi, 3 pi over 2, and 2 pi. Right, this is your sine. So, and then if you want to continue, you can continue drawing more of it. And it goes from the range from -1 to 1. Okay. And you keep on going that. So this is sine x. So how do you draw a cosine x? Is you dot you got two types of asymptote now. You have a horizontal asymptote, and your horizontal asymptote in this case, it belongs to the 1 and -1. That is your horizontal. Your vertical asymptote is that 3 points that used to be in your x-intercept. So in this case, it will be at 0. It will be at pi. It will be at 2 pi. And what do you notice here is that every time when you draw this like a box, you find out that you get the whole hill, and then the next box, you get a whole valley. So if you want to figure out what happens to your vertical asymptote, you do not actually need to find it. You just figure out, okay, this is the whole valley. That is your vertical asymptote. And this is your whole hill. That is your another vertical asymptote. So how do you draw your cosecant graph? You just reflect. So if this is a hill, then your cosecant graph will be the purple one. And make sure that it touches here and it will not cross at this. That means it go parallel to the vertical asymptote. So it will touch us here, it go to the vertical asymptote. So this is the purple graph that I draw here is your cosecant graph. So it actually go up and down, up and down. This is your cosecant graph. You guys all right? Same thing happens to your secant graph. And as you guys know that your secant graph is based on cosine, the reciprocal of secant. And if you remember for cosine graph, it is a value, right? So it goes from again 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, and then if I want to do it this way, it's fine. Another value. And another value. Okay. So so this is your cosine graph. So now we need to draw your secant graph. So it does also have your horizontal asymptote, and your horizontal asymptote in this case will be from 1 to -1. Same thing as your cosecant graph. But if you look carefully on your vertical asymptote, it's no longer at 0 and pi and 2 pi. It's going to be at pi over 2, where it intersects at your x-intercept. You see this one? 3 pi over 2. And then it will be over here. It'll be over here. So some of you will ask me where you think I can find your vertical asymptote. You can actually find it by looking at your x-intercept before it moves up and down. Because once your graph moves up and down, your x-intercept will move up and down. So you make sure you understand it's before they move up and down, before the d. And another trick I always tell my students is make sure when you draw the whole box, it should have the whole valley or the whole hill. So like this one is a whole valley, you're in the right track, then this is going to be a whole hill. So the blue graph that I draw here is your secant graph. So usually how I teach my students draw a secant or a cosecant graph is you learn this in your previous section on 6.4. Make sure you draw your sine graph first and draw your cosine graph first. And then you just do what I just did here is you draw the vertical asymptotes, you draw your horizontal asymptotes, and then you just reflect. A hill become, a hill become a happy face, a valley will become a sad face, something like that. And this will be your secant graph. Now the domain, the range, let's talk about these two. Okay, because you need them, you should know them. So for domain is all real numbers, except this is the same trick I teach you guys before. You take the first one. The good news for this is 0, so we don't need that. And your period. So your period in this case is 2 pi, so it's 2k pi. Don't forget, cosine is based on sine, so your period in this case is 2 pi over b again. Same thing on this case. Okay. Our range, because it goes from negative infinity to -1 because it will touch. So that's why you need a bracket here. And then union 1 to infinity. So the range for a cosecant graph is you go from -infinity to -1, and yes, it touches it. And then it jumps from 1 to infinity. Okay. For the secant graph, your domain and range, this will be all real numbers except, again, because it starts from pi over 2. So it will be pi over 2 plus, actually, this is not 2k pi. This is just k pi. 2k pi over 2. So this is also going to be 2k pi over 2. Why you need over 2 here? The reason why you need over 2, usually you just take, right, 2k pi or whatever you have. This one you have to over 2 is because this is the whole sine. But when you draw your vertical asymptote, you break it into 2 parts. One in quadrant 1, 2. The other one is quadrant 3, 4. That's the reason why you have to make it over 2 here, is because you split this into 2. The whole period, you split it into 2. So that's why you have to make it over 2. So this is the same thing. You have to take the pi over 2 plus 2k pi over 2. And again, these two can be canceled. So it's just k pi in this case. So every time when you guys do a secant and cosecant graph, it's exactly the same thing I teach you for tangent and cotangent, but make sure you make it over 2 because you have 2 pieces here, which is, for this case, will be pi over 2 plus k pi. Okay. Pi over 2 plus k pi. Your range is the same as this range, which is -infinity to -1, bracket, union 1 to infinity. So this is a range for him. Okay. So yes, when you do cosecant and secant graph, you have to go through all the same step of graphing sine and cosine, like what you did in 6.4. So it's a lot more work than what you think about to graph it. When you see a negative, you just flip it. So when you have a negative of this, so when you want to draft a negative of this fellow, you just flip it on the x-axis. So your purple graph, this is going to be happy face. This will be a sad face here. And this is a sad face, then this will be a happy face. So the gray one that I draw is the negative of cosecant. You just need to flip it around. Anyone have any questions with this cosecant and secant graph before we do some examples here? And as I told you in your test, there is no such thing as multiple choice. So you have to draw this by hand. Okay, I'm going to go through one example here, which is number 12. So how do you draw 1/4 secant pi x over 4? So in order for us to draw this, you have to draw 1/4 cosine pi x over 4. Because secant is a square of cosine. So this is what you guys did in 6.4. So remember, you need to find your amplitude, your period, your phase shift, and D. So this is your time to tell me this. This is not that. So we are concentrating on the 4th. All right. Thank you, Matthew. Not yet. So I'm taking attendance now. So please put down your attendance. Those. Okay. Anyone know what is your amplitude in this case?
1/4.
1/4. Very good. Period is 2 pi over b because it's cosine. And what is b in this case?
Pi, is it pi over 4?
Yep, it is pi, like slope. So if you look at this, slope. So dividing pi over 4, which is the same thing as multiply by what? Flip it, right? 4 over pi. So this will cancel, become 8. So this is your period here. Do we have any phase shift? Do we have C in this case?
No.
No C, so no. Do we have D? Do we add or subtract anything in the back here? Also, no. So you do not need to do phase shift, and you do not need to do the D. So now, remember when you do this, you have to give me your coordinates. Do you guys remember what is the 5 coordinates for cosine?
Pi 0, 0.
No, it's a valley. Forget. What is the first point here? 0, 0 is here. So
0,
this
1.
is 0, 1.
Pi over 2, 0.
Pi over 2, 0.
Pi negative 1.
Yeah. Followed by
3 pi over 2, 0.
and the last one.
2 pi 1.
Yep. This is exactly what you guys learned last week, right? Now you do your bx minus c. In this case, pi x over 4 equals to 0. And you do the pi x over 4 equals to 2 pi. Because your period is 0 to 2 pi in this case. So when you multiply this by 4 divided by x, x in this case is still 0. So you start from 0. This one, you multiply by 4, become 8 pi. And then when you divide by pi, the pi will cancel. So x in this case is 8. That means that if you remember step 2, the interval from this is from 0 to 8. Remember the first 10 minutes when you guys asked me how you do the interval for step 2, this means 0 to 8. Do you guys remember how you figure out what do we need to add on here?
Pi over 4.
You take your period divided by 4, right? And your period in this case is what? 8 that you found early on over 4. In this case is 2. So we just need to add what? 2 to each one of this. So 0 plus 2 is 2. And then what happens? 2 plus 2 is 4, right? And then 4 plus 2 is 6. And then 6 plus 2 is 8. So this is how you figure out what do you add on is you take the period divided by 4. This is again from 6.4 you guys learned. And then how do you figure out your y value? You want to remember how you figure out your y value?
Initial y.
You take the a times the initial of the y value, and then you add it with d. Okay, because your a and d, remember your phase shift, your a, your amplitude, and d is the one that affect your y. Do we have, since we don't have a d, so we do not need to do d because we don't have a d. So a in this case is 1/4. You just need to take all this y value, the initial y value, times 1/4. So 1 times 1/4, you get 1/4. 0 times 1/4, you get 0. -1 times 1/4, you get -1/4. 0, still 0. And this is 1/4. Because your a in this case is 1/4. You guys all right here so far? And then this is the one that you have to put in your graph paper, right? This is what you guys learned in 6.4, and that's why you need this when you guys do your 6.5. So what do we have here? 0, 1/4. That's your formula. The formula is P over 4. And P is your period, which is 8 here, Adam. This is a formula. And the reason why you take the period over 4 is because you got 4 different quadrants. That's why you got 4 quadrants here. So that's why you divide by 4. So I take the period, in this case is 8, divide by 4, in this case we'll get 2. Okay, Adam, you all right? You got 2, 0. 4 will be at -1/4. And then 6 will be at 0. And then 8 will be back at 1/4. So this graph, I know it's very bad, I'm sorry. This graph is your cosine graph of this, 1/4 of cosine pi over x. And if I want to continue, I just continue drawing this. Again, it's a valley. If you want to figure this one out, this will be 16 because one whole period is 8. So another period will be 8 plus 8, 16. Okay. Now, so this is how the cosine graph, but I do not want the cosine graph. I want the secant graph. So again, in order for you to do a secant graph, you need to know your horizontal asymptote. In this case, will be a quarter and a negative quarter. Does anyone know how to figure out your vertical asymptote here? If you forget, it's your x-intercept before it moves up and down. The good news is because there is no moving up and down, means it will be your x-intercept. So that will be your 2, 6. Does anyone guess what is the next one will be? What's this one will be? This is 2, this is 6. What is this one?
12?
No.
Oh.
What's the difference between 2 and 6?
4.
So this one has to be at 4, right? What's 6 plus 4?
10.
10. And this one will be 14. Okay, so this is your vertical asymptote. So now you notice that your graph here, one of them, this is the whole is valley. So you just reflect it. This one you will do reflect it, go up. This one is going to go like this. This one you go like that. So your graph will look like what the blue one that you see. Can someone tell me what is your domain here? All real numbers except
2.
2, because we started 2, plus, don't forget your period last time.
4.
Yep, you divide by 2, 4K. Okay. Used to be 8K. Remember last time for tangent and cotangent, you put 8K, 8 pi K or 8K, whatever in the period. But because you have to divide that by 2 for cosine and for secant and cosecant, so it becomes 4K. So this is your domain here, all real number except 2 plus 4K. And then range, anyone knows your range? It goes from negative infinity to where?
Negative 1/4.
Negative 1/4 with a bracket means it includes that number. And then union, a quarter to infinity. So this is your range in this case. So so you guys all right here? So mostly what you did in 6.4, which is in here, all this is what you guys did in 6.4. The only difference when you want to graph secant and cosecant is you have to do your asymptotes, your horizontal and your vertical asymptote. And then after that, the rest is pretty much easy. So if you know how to do your 6.4 homework, secant and cosecant is the same thing. You just need to do a little bit of work. So for this case, it will looks like which one? It looks like it's one of this. So it is 2, and this is negative 2. So it should look something like this one. Because this amplitude is 4, you can tell. And this is a quarter, so a quarter is a little bit smaller. So that's why the answer will be this one. And the period in this case will be 8, which is this one that you calculate. Okay. You guys all right? Questions? Questions that you have? So mostly 6.5 is not too difficult if you know how to do your 6.4 homework. So again, if you want a nicer graph, because some of my the graph that I draw is not as nice as you know, you can tell some of my graph is not, oh my God, I hate this. They don't have that, they should just take it out. So if you go to the to your textbook, they will have a nicer graph of that. So because my drawing graph is horrible, that you can tell something else like what's going on. So if you go to 6.5 on your textbook and you go towards the end, I just click exercise here. So I just go one page before exercise, maybe 2 page. So if you go all the way down on this, they will have a nice all 6 trigonometric function here. So if you want, I mean, it's nicer, definitely is. So they will draw all the sine and cosine and everything here. So if you guys need a nicer graph, please get it from the textbook or go online. They have tons of it. So they will even tell you what is the domain and range and the period. Okay, you can tell they're all giving you that. So I will strongly suggest you guys do that. Okay, it's very important in this case. Okay. Next, we're going to talk about here is 6.6, just a little bit of introduction of 6.6. So I still want you guys to do both 6.5 and 6.6 homework. What is 6.6? 6.6 in this case is what we call as the inverse function or inverse trigonometric function. This is where in your calculator you see the sine -1 and cosine -1. So that is the inverse. So when you guys see this in your calculator, this is not what is reciprocal of sine? Cosecant. This is not cosecant. Okay, a lot of people think this is cosecant because sine -1 is opposite of reciprocal of sine, which is cosecant, and tan -1 they think is a cotangent. This is not. So in your calculator, if you see this button, this is called the inverse trigonometric. So example is if I say tangent theta equals to 1, if I want to move this tangent to the other side, you will use the inverse, or sometimes we call the arc. Okay, so you know when you're solving equation, right? You want to solve theta, you have to move that over. So when you move that over, then you will get the tangent -1. This is what we call as the inverse, which is what you guys will learn in this section of 6.6. So so if you use your calculator to do the tangent -1, it's going to be 1. How do you use, if you want to use the unit circle one, how do you figure it out is you figure out which one of this, if you divide, will give us 1, and that is this 45 degrees. So for tangent, you have to divide. So when you divide this, you get 1. So that means that your answer in this case is pi/4. Okay. So for this case, theta will be pi/4. Usually we want radian. So if you use your calculator, go ahead and use your calculator and type this one out. Yep. Go ahead, everyone. Take out your calculator, type tangent -1. If you put it under, if your mode is under degree, then you will get 45 degrees. If you put it under radian, does anyone know what is pi/4 is? Pi/4 is pi/4. 0.7 something. You guys got either one of this answer? Which this is the same thing as pi/4. Make sure you know what mode you are in your calculator. You guys all right? Questions? Okay, so if you put degree, it's 45 degrees, which is this one. If you use radian, it will be 0.7854, which is pi/4 if you put it down. Okay, your calculator would not give you this. So in a test, which one do I take? This one definitely 45 for sure. Which one do I take in the test? The 0.7854 or pi/4 in the test or in the finals? I will take him. So do not give me this. Okay, and this is what we call as your exact value. So in the test, I will say I want the exact value, and this is what I want. This is not the exact value. Okay. Questions? Now, in order for us to do the inverse, so this is back to the inverse function that you guys learned. We have some rules to figure out some inverse function. Okay, we'll talk about this and then we'll end today's class. The first rule is it has to be one-on-one. So remember last time when you learned the exponents, the inverse function is log. Okay. What is the meaning it has to be one-on-one? One-on-one means it has to pass your horizontal line test. And also it has to pass the vertical line test. So you have to pass 2 tests. Okay. So that means that one-to-one means one x value, you get one y value. When you put the x value, you only get one y value. So last time, if you remember, x squared, which is this one, x squared is not one-to-one, but we know the inverse function for x squared is square root of x. The opposite is square root. So, so if you have such rules that we know it's not one-on-one, what do we do here is we do what we call as domain restriction. We restrict a part of it. That means we just take this on the positive side. Okay. And you will have the inverse function on that. Okay. So if you take, this is called the domain restriction. If your x is greater than 0, we take the positive side, then you will end up with this. Okay. So, so if you have not a one-to-one restriction, we just need to, we didn't fulfill the one-on-one, we have to do what we call as a domain restriction for this. So this is the same thing for sine, cosine, and tangent, because if you draw the sine graph is a hill and a valley, a hill and a valley like this. And you notice that it will not pass the horizontal line test, because you guys know what's a horizontal line test, right? Every horizontal line, you can only intercept how many points on the graph? You can only intercept one time. You can tell when you draw this horizontal line, it intercepts a lot, but it passed the function, the vertical line test, because every time you draw the vertical line, it intercepts only one time the graph. But the horizontal line is the one that it doesn't pass. So what do I do here is, so I will need to do what we call as a domain restriction, like what we did in the x squared. So I will have to erase it. And where do I erase it? I will erase it till this, till this and this. So I erase all of it. So I restrict the domain. So imagine all the things that cancel out. I restrict the domain from negative pi over 2 to pi over 2. So if I restrict the domain from negative pi over 2 to pi over 2, you notice that this passes the horizontal line test. Because when you draw a line, it only intercepts one. So this will have an inverse function. And the inverse function in this case, we should write this one, is sine, we call it the arc sine in this case. Okay. If you also remember back in your college algebra, the domain of a sine is the same thing as the range. So what is the range of this inverse function? It will be from negative pi over 2 to pi over 2, because the domain is this. The range for the sine is negative 1 to 1, because it goes from negative 1 to 1. So what is the domain of this inverse function? It will be from negative 1 to 1. So so this is how we do the sine inverse function for it, and it has to have a domain restriction on it. For those students who want to figure out what happens to cosine and tangent, I would recommend you to watch the video. Yes, I'll post some videos online. So you can find it from your D2L. I will post it in D2L so you will see it under material, I'll post it in there so you will see it. Okay, so make sure you guys go and watch 6 points something, I think it's the last one. So 6.6 is the one that you need to watch. So if you watch 6.6, they will tell you about the introduction of inverse. So if you watch this 6.6, the first one, 6.6, the first YouTube video, they will teach you how to do the inverse function for each one of this. They will so they will tell you about the domain restriction. So they will tell you what happens to your sign, so on, and so they will. This is something that I will recommend to watch. They will tell you about what is the horizontal line test, a vertical line test. So they will tell you more about what's going on to sign, and then they will bring up the unit circle and all these things. So I would recommend you guys to do this because it's very it's a 7 minutes watch of this inverse, sine and cosine. So your homework for this week is still going to be chapter 6.5 and 6.6. So I would recommend you guys to work. 6.5 is not that difficult. 6.6 is the one that I haven't finished doing anything. So I will have maybe another Zoom session on Monday, which is what Monday is that? Not 8. If you guys need help with 6.6 or 6.5. So I might have another Zoom session on 6.6, which is optional. Okay. So make sure you guys put present on it. And yes, this will be recorded and posted in YouTube. So I'm going to stop sharing here. So make sure you put a present out on it. For those who are in the accommodations, I will email the Tom to figure out what's going on because your test is in 3 weeks. And then I will send you guys an email personally so you guys know what's going on with those who have accommodations. Anyone have any question for me before we end today's Zoom session? If you don't, you may leave. If you do, please do stay back, and then I will help you with it. I'm going to stop recording.